Warm greetings and very good morning, dear students and friends. Today we are going to take about the video lecture on a simply supported beam, subject an UDL of 10 kilonewton per meter run over the entire span of 5 meters. So, what will be the shear force value and where the maximum shear force will occur? And also find the maximum bending moment value and also its point of occurs on a simply supported beam. You know that the case of a simply supported beam, the UDL throughout the span of 5 meter and UDL of 10 kilonewton per meter run. So it is a symmetrical loaded beam. So the center point I call it as capital C. The left support is capital A and right support is capital B. For example, so this is the center means C. This is the support reaction at A, reaction at B, A, C and B points. Being a symmetrical, I will take the first half AC or you can take the CB also. So what will be the reaction at the support ends? So we have a beam, a column or the wall. So here, right, the total load is UDL intensity into span. UDL intensity is 10 kilonewton per meter. So 10 into the span is 5. So 10 into 5, 50 kilonewton. So at support A and B, the reactions are upward, which is of 25 kilonewton each. The total load is 50 kilonewton. So now coming to the shear force. Shear force at the point A is here you can have only the reaction if you take left hand side. So it is plus 25 kilonewton. Then coming to at mid span, what will happen? So you have at C the reaction is 25 plus minus this UDL value. What is that? Minus 10 into 2.5. So it is 25. So 25 minus 25. So the shear force at midpoint is 0. Similarly, the shear force at B. So I will take the right hand side. Right up is right negative value. So it is 25 kilonewton minus. So the value of shear force at A is 25 kilonewton plus at B is minus 25 kilonewton. At center it is 0. So if you draw a horizontal line here, the shear force at this point is plus value. You plot above it. Here minus 25, plot below it. So it is a linear triangle for the shear force diagram. From 25 plus 25 to minus 25, the shear force at point C is 0 at midpoint. So wherever the shear force is 0, right, you at that point you will get a maximum bending moment. Now we can see the bending moment value. So here the shear force we have known that plus 25, and what about the bending moment at support end? So it will be 0. I have taken the left side 25 into 0 0. Similarly at B the bending moment at this point is 25 into 0 0 if you take right side of this section. And what will be the bending moment at the middle point at C? You take a moment due to reaction 25 into 2.5, then minus of UDL, 10 into 2.5 square by 2. So if you are simplifying it, that is 25 into 2.5 minus UDL is 10 into 2.5 square by 2. So you put the value of net bending moment. So that will be maximum. So that is you are getting WL square by 8. So for a simply supported beam with UDL throughout, right, you will get WL square by 8. So small w is the load intensity. That is UDL intensity. That is 10 into span is 5, 10 into 5 square by 8. So in terms of kilonewton meter. then from that you can know that the maximum shear force will be at the support end, which is of 25 kilonewton, either positive or negative. Then zero value at the midpoint, that is at C. The maximum bending moment occurs at midpoint where the shear force 0, that is 10 into 5 square by 8. At the support, the bending moment at 0. Now you draw the bending moment diagram. What will happen? So AB horizontal line, if the plus value of bending moment is you put above the horizontal line, below that you are getting negative bending moment, so you have to draw below the bending moment diagram. So 0 0, and it will be a parabolic curve because of Wx square by 2. So parabolic curve 0 at the support end, maximum at this middle point, that is 10 into 5 square by 8. So this is how we are finding the shear force and bending moment diagram at significant points. After that, we are drawing shear force diagram and bending moment diagram. First, you have to draw the load diagram. Then below that, you draw the shear force diagram. Below that, you draw the bending moment diagram. So you can draw this diagram. You can easily find out the unknown factors. What would be the question is asked, you can answer for it. So being a symmetrical loaded beam, so it is easy. If it is a point load and partial UDL, so it will be somewhat tough compared to the simply supported beam with the central point load or the UDL. Thank you very much for patient listening. We can see the other type of problem in the next video. Thank you very much. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.